In this video we will look at scene structure, frame dips down to 20 FPS, shadow quality, shaders and rendering backends. First I'll show you how to build a clean and simple options config using autoloads and signals, and then we'll get into the individual performance optimizations. This is an intermediate Godot tutorial based on my own experiences with optimizing the game you're seeing in the background. It is a 3D visual novel I made for the Rihanna Visual Novel Jam called XXU. Have fun! First I want to talk about project structure to enable a fairly lightweight options menu. I'm not going to show you all the code because if you're watching this you know how to structure your scenes well enough, but here's how the setup works. We have an autoload called options that holds all the options, for example, like did they're enabled. It's a boolean and we can quickly just skip through all of the points where we reference it. Of course we have the variable declaration with the setter. I will get into the event here in a bit. We have the ready function in which we just get the property value from a config file. This is literally just the config file documentation from the Godot docs, but just, expanded a tiny bit. And then we have it down here in this function called save preferences, where we, of course, save it. Again, basic stuff. The option menu initializes itself based on the state of set property. So in the ready function, we just set the value of the checkbox to the appropriate value. And when we toggle the checkbox, we set the property in the options autoload, which will then emit the event bus signal. An event bus is kind of like a pattern that has been talked about a bit more in recent times in the Godot community. I'll link some good resources in the description. I'll probably have them on screen now as well, but basically it's just an autoload that you dump a bunch of signals into, and that kind of decouples everything from having to know about all the other things in your project. And then we have all of the different nodes that just listen to this one signal. So if we look here, all of the settings sensitive nodes implement this function, this listener function. On settings change, we also call the function in the ready function so that we can actually initialize with the correct values, and we see it literally just listens for all of the different options that change and then does things dynamically. This is based on whatever node this function is implemented on. For example, you can see here, this is the overlay. This is another autoload that handles all of the different shaders, and it just toggles the dithering based on the state of the autoload. This makes all the options in real time too, which I quite like. The one weakness of this is that when you set multiple properties in the same method, you get redundant signal emissions. I have this graphic setup screen when you first boot up the game, and it emits a settings changed signal a bunch of times when you select one of the presets. If you want to fix that, go ahead, but I didn't find it to have a big impact on performance, at all. Generally, my philosophy around performance is not to worry about it until it becomes an issue. Why worry about something that impacts no one, but specifically with XXU, I get so many reports of crashes, bad performance, and even one stupidly huge memory leak, 1 week before release. So I scrambled to bang out the most egregious issues, and this video will be a crash course on all the different optimizations that I made during that. Let us begin by talking about cameras and subviewports. For this we will be using the visual profiler Godot provides. The visual profiler is a tool in Godot's debugging suite that allows you to see how much of your frame time is taken up by which types of CPU and GPU operations. In XXU there's a phone that can hover freely, kinda GTA style, but more computationally expensive because it's an actual 3D model. This is rendered to a subviewport and then we render it to the main screen. I did end up implementing a setting that would just not render 3D at all and instead render the phone's subviewport directly to the main camera. You can see it here in the graphics option. It's called slideshow. When we toggle it, all of our subviewports get hidden, and that then just removes all of our 3D draw calls down here. And as you can see, it changes the graphics because now we don't have a 3D model anymore. It's literally just the raw subviewport. And if we re-enable it, we can see our subviewport becomes visible again, and we get our draw calls once more. This generalizes, by the way. Hiding subviewports automatically removes their draw calls to the GPU. So when we have a background with the phone, we don't need to keep the fancy 3D scene in the background as well, and we can just set its visibility to false. Shadow quality settings follow a similar pattern. In the options menu, I provide an option button with 3 different quality modes, and when we change set index, the signal for that gets emitted again, and Subviewports react to it. They have a built-in shadow quality setting called positional shadow atlas size that I set like this. In a larger project, I should automate this or use constants, but for XXU, this hard-coded approach worked just fine. Now onto shaders. Shaders can be expensive and you might have to avoid using them excessively. Generally, I find that when you start off with Gamedev, you want your game to look nice, but you don't really want to invest much into the tech side of things. And eventually you discover shaders and post-processing through websites like Godot shaders, and you start putting them everywhere. This is good. It makes your development sense of style, it makes the game look nice, and hopefully it doesn't tank the performance. A small philosophical aside, it's fine if your game cannot run everywhere, by the way. Literally no game is playable everywhere. Providing shader toggles in your options menu is a way of making the game playable on a weaker hardware, which broadens your player base, and especially lets you tap into the market segment of perpetually broke trannies, which is the best player demographic. But when you do this, you have to think about the intended experience of your game. Arguably, the dither in Loner and XXU is too crucial to be a toggle since it ties into the visual identity established by Snuff Puppy Shelter. However, both of these games are fundamentally about being in conversation and reflection with the player and digging around in their soul and entrails. The dither helps with the gene of dissociation, but ultimately the games are about experiencing the writing. But let's continue with the technical side of things. XXU uses somewhere in the realm of 7 to 8 screen space shaders. Shaders with the uniform sampler to the screen texture, hint screen texture line of code in their shader. You will see these online a whole bunch because they're a really simple way of adding a bunch of visual punch to your game. They're good. However, they're also computationally incredibly expensive because for every canvas layer color rect setup that you do with these, Godot has to make an internal copy of the entire screen, which depending on the application resolution can be a few million pixels. With every one of these, you are doubling your frame time as a baseline on top of the shader execution time. And on the topic of execution time, this is where we get into making your game run better. For the longest time, I was wondering why my phone scenes ran like garbage when compared to the rest of the game, and it was only through the visual profiler that I figured out it was actually the blur behind the phone that was swallowing up a bunch of resources. So I made that and all the other shaders a toggle and only included them in the highest graphical presets. You can see when I disable it here, the scene looks a bit less dynamic, but we chop off a bunch of frame time in our visual profiler. This one is fairly specific and situational, but XXU has one scene that also ended up being really resource heavy. A few minutes in, you have this what I internally call showdown, where you aim at one of the girls, and you have the choice who to point the gun at. The background in all of this is 2 really expensive shaders stacked on top of each other, and it looks really cool and awesome, but it literally crashed the game when I gave it to Jane for proofreading. And I didn't want to just have a solid color background or a static image, but I also could not be bothered to find a less resource-hungry replacement. And then I remembered Xenophora Static C, a visual novel that Stella, one of my composers, worked on. That game uses video playback for all its backgrounds using the video stream player node, so I fired up OBS, recorded this background, and now when XXU has the options enabled that you want to reduce the showdown effect, it will load the video stream instead, which will then look like this. It's a bit stuttery, you lose a bit of resolution, but again, it dramatically chops off parts of the frame time. It also very clearly loops after 1.5 minutes, but I don't expect most people to stick around this scene for that long, so it's fine. Lastly, let's talk about rendering backends, specifically Vulkan versus Direct3D 12. This is a fix specific to Windows, but Windows will also be your primary distribution platform by a massive margin. This will heavily depend on the needs of your project and where you find the most egregious performance dips. Vulkan as a rendering backend was literally fine for everyday Aurora side, which you're seeing in the background right now. But with XXU, I saw it destabilize massively for reasons I don't know. I'm unsure if it was because of the upgrade to 4.6 or some other reason that eludes me, but with Vulkan I got FPS fluctuations between 20 and 240 FPS. Switching to Direct3D 12 in the project settings stabilized me to 60 FPS, constantly. You can find it in the project settings under rendering device, and then just like select it from the drop down. Changing the setting also seemed to make the game run a bit better on basically all the Windows machines that I got to test XXU on before launch. Here we sadly get into the territory of not even knowing if this really was the cause of some issues. At one point I received a report of a 12GB memory leak when switching window modes, besides that option toggle being a bit janky in general. And my code can't have been the issue because my code is not that low level. My code in that instance was literally one line, but it sure happened. Switching to DirectX 3D12 made the apparent process of changing window modes much smoother, and I hope I won't have another GPU cooking session hidden somewhere. This is a really depressing note to end up on, so let's talk about hacks and pride before we go. Gamedev is filthy. XXU, like all game projects, is a project that's mostly really nice but falls apart sometimes, and then sometimes you need to patch it up with disgusting hacks. I couldn't figure out how to translate touch events on mobile, so the background I built is a massive grid of buttons, and I use their pressed events to figure out where the player is aiming. On 60 to 70% of machines, I got to see XXU before launch. Literally, no issues were apparent with anything whatsoever. Game development is really messy, and sometimes you have to weigh between the jank that keeps you going and making things accessible to more people, sticking with your schedule and cleaning up your code base. These are all big topics, and finding the balance between them can be daunting, and it's all a continued learning experience that we can go on together. You will notice that I didn't really talk about shader code optimization. That is because I don't know anything about shader code optimization. I'm not a shader programmer. Literally all the shaders in XXU are taken from Godot shaders. These are all tips that hopefully help you when you make your first resource-hungry game and you need some pointers to make it playable. The entire contents of this video are based on the panic of having to optimize my game 1 week before release, and for that my solutions worked fine enough. If you have any notes or remarks, I'd love to hear them in the comments, honestly. With that, I say thank you for your time. I hope this video was of some help to you, and if you want to support me, check out my Patreon, link in the description, and subscribe because I want to make more videos again in the future if time allows me to. Thank you for watching. Bye!